Alright, now we're ready to hop into the lab and configure RIP version 2 between our routers. Here's what the topology looks like that we're going to be configuring. Let's first review what our configuration is going to look like. First, we're going to enter router RIP to get into our RIP configuration. And then we're going to enter version 2 because by default RIP is going to operate as version 1. So we apply the version 2 command to make it run RIP version 2. And then we say passive interface default, which is saying even if we enter a network statement to make a router interface active for RIP, we do not want to send RIP updates out of any interface unless we actually define those interfaces with the no passive interface command like we do later on in our script here. Next, we'll enable RIP on the connections between R1 and R2 with the 172.16.0.0 network statement. Then on each router, we want to advertise their directly connected 10.network. So R1 will have a network statement for 10.1.0.0. So it advertises that network to R2. And then R2 will have a network statement of 10.2.0.0 to advertise its connected network to R1. And then we'll go ahead and say no passive interface F00 on each router because F00 is the interfaces that are used to connect R1 and R2 when we want to advertise RIP updates out those interfaces. And then finally we say no auto summary because we do not want auto summarization enabled. Alright, let's jump into the lab. I'll go into configuration mode and say router RIP version 2 passive interface default. And I think we just have no auto summary. Okay, great. If we want to review our config, we can say show run pipe section RIP. And RIP will actually, you can see here how it just entered 10.0.0.0 instead of 10.1. It'll still advertise the 10.1 appropriately. That's just how it converts the network statement. Now let's do the same thing over on R2, except we have the different network statement, which actually, I'll show you a trick here. We can actually just copy and paste the same configuration over on R2, and we'll get the desired result here. Let's paste that in. Now for some verification commands, just to show you what our interfaces look like real quick. We'll do show IP interface brief on each router. So you can see I'm not lying, my F00 interface is on the 172.16 network, and then I don't have the interface labeled on the diagram here, but F10 is our directly connected LAN segment on R1. So you can see that R2 just has .2 for its 172.16 IP address, .1 over here on R1, and then of course it has the LAN segment. Now let's take a look and see if we learned our routes like we were hoping. I'll run show IP route on R1. And you can see that we did in fact learn the 10.2.0.0 network from R2. And you can see it's labeled as an R route. If we look in our codes here, we see R is a RIP route. And it has an administrative distance of 120. And a metric of 1 because it's one hop away. So that's why we have a 1 for the metric. Now let's go over to R2. And we see that R1 successfully advertised its 10.1.0.0 network. We see it's via R1's next hop IP address, and it has an R for a RIP route, and AD of 120, and a metric of 1. Let's take a look at a few more commands we can use for verifying our RIP routing topology here. We can run the command show IP RIP database to see the routes in the RIP database. One of my all-time favorite commands, show IP protocols. That will show you information about any dynamic routing protocols that you have running on a router. So here we can see for the RIP routing protocol, actually a lot of good information here, and some of the information in this output, this command is the only way that you can see that information. So it shows our timers, which interfaces are actively participating in the routing protocol, if auto summarization is on or not, the networks we're routing for, and our administrative distance for that protocol. One cool trick for looking at your routing table, you can actually say show IP route and then RIP at the end of the command just to see the RIP routes. So you can see the difference here. Maybe you have hundreds of routes in your routing table and you really just want to see the specific RIP routes. That's one quick way you can verify that. Next, we're going to configure a default route advertisement from our R2 router in the lab. First, let's jump into R1 to prove that it does not have a default route in its routing table currently. And we can see that it does not have a gateway of last resort set, and it does not have a default route in its routing table. So we'll simply go to R2, go to router RIP, and then say default dash information originate. And just by setting that command, we should now see a RIP advertise default route. And we do. So you see we have this R route, default route. We now have a gateway of last resort set via next hop of R2. And it's really that simple. Just by that one command, you can advertise a default route to the rest of the topology.